Boom! Right. So we're continuing where we left off in the last video, and we're going to use the other polynomial to carry out the same long division, just using some different numbers again, just to demonstrate the whole procedure. And of course, we're going to follow it up with some exercises for you to practice. You put pen to paper and get it. So it's not just about looking at me doing it in a video and understanding it and see, yeah, he explained it real good, and yeah, I understand it, so yeah, I know it. No, looking at it in a video and understanding it is one level of comprehension. There is another level of comprehension that requires you to actually physically sit down with the exercises, put pen to paper and work it out. All right? So even though you're getting this information in an online setting, there are certain fundamentals that don't change. Writing, pen and paper, foundation. There we go. So we have the polynomial here, and remember, this is the one where we had the term in x cubed missing, and if you recall, you would remember that that missing term in x cubed would have complicated the long division somewhat. So you would have seen that, and at this stage you would have worked out some questions where one or two terms were missing. All that is part of the game. You wouldn't always get it looking nice and smooth, flowing from top to bottom. All right, so just as we did in the last video, we're gonna do something to this polynomial to make a new polynomial and get a remainder. So what we're gonna do here is minus, because in the last one we added. So again, we're gonna take a random number, let me say 89. So this entire polynomial minus 89, all right? 105 minus 89 is 16, yeah? Right, so you want to know how we work that so fast? 100 minus 89 is 11, all right? And when you get 11 from that, you just add back the 5 from the 105 and you get 16. So all of that is little tricks that you can use in your head, right? And again, I'm sharing some of these things with you all because you're at a slightly higher level now than the regular maths. We don't add maths, so you're supposed to be clicking at a higher level. And if you feel as if you're not clicking at a higher level yet, just stay in the game and keep up the work ethic. And before long, you will find yourself clicking at a higher level, right? And you might even be in a position now to help out some of your people, some of your friends and whatnot. All right, so stay in the game. We're going, and we're going good. We're doing it. So when we minus 89 from this, we get a new polynomial. A new polynomial will read as follows. It will be x to the power of 4 minus 42x squared plus 64x plus 105, bam bam, plus 16. So we still have a positive quantity here, but we would have taken out 89 from 105 to get 16. So this is a new polynomial. So therefore, if we divide this new polynomial by one of the quadratics that we had used in a previous video, we expect to get a remainder of minus 89. So let me do it. So now we are going to actually do the division, and we're going to say now that what color to use, boy? Let me go back with the, I think we had this blue in the last video. Yeah, trifling details but small thing. So we're working with the new polynomial. Yes, I think that is why we had this blue the last time. So we're saying x to the power of 4 minus 42x squared plus 64x plus sorry, my mistake. This 16 is supposed to be here. Right. My mistakes. Plus 64x plus 16. Alright? And we're dividing this by, let me see, we're taking one of the quadratics from what we had used before. We have this on this paper, man. Okay, that's that one. No, this is 105. Okay, and this time we're going to divide by x squared minus 2x minus 3. Alright? I thought I just had to excuse me a little bit. I'm trying to make sure I write these things properly. Alright, so we divided the new polynomial, not the original polynomial, because if we had divided this original polynomial in black by this, we expect to get a remainder of 0, because we had already established that x squared minus 2x minus 3 is a factor of x4 minus 42x squared plus 64x plus 105. So we're taking a new polynomial now, and we're going down the road. So let us remove this guy and this guy from the picture to clear some space on the board. So we're going to the procedure again. X squared into x4 is x squared. Alright? And x squared by x squared is x to the power of 4. X squared by minus 2x is minus 2x cubed. Remember what happened in the last video, right? Where we had this situation. And x squared by minus 3 is minus 3x squared. And you have the long line there, and you're minusing. Right? This minus sign is everything minus in there. So x4 minus x4 is 0. Boom. We don't need to write that down. Minus 42x squared minus 2x squared. Sorry, minus 2x cubed is just that. Minus 42x squared minus 2 is plus 2x cubed. We leave that as is. Alright? And 64x minus 3x squared is plus 64x plus 3x squared. Nice. So just as we did in the previous situation like this, we bring all the like terms together and we simplify. So this now here is going right back to question 2 in your C-Sec Maths, where you could have an array of different terms and you bring the like terms together and you simplify the expression. So minus 42x squared plus 3x squared is how much? Minus 39x squared. This is plus 2x cubed. Yeah, plus 2x cubed. Alright. Plus 64x. We only have 2x cubed there, right? So we're minus. Alright. And then, of course, remember that we have to rearrange this expression here. Excuse. To get the highest power to start with, and we're going down the road. So we have 2x cubed. So this here is a cubic polynomial now. Right? So 2x cubed will be the first term, minus 39x squared plus 64x. And now we dividing the x squared from here into this, not these two. These two lines would just be a regular arithmetic going forward. So we divided x squared into 2x cubed here, and you will get hold on. Right. You will get x squared into 2x cubed is 2x squared. It's 2x, sorry. Yeah, I was just verifying that the answer was correct. I tried to make sure I don't make any mistakes here, because if I had made a mistake in transcribing, I would have had to start the whole recording over. And that is extra work. Yes, sometimes I will have to start over a whole recording. You all wouldn't normally know when I had to do that, but that is just some of the things I have to go through sometimes to get the job done. It will be the same thing with you. You're doing a problem, you have to do over the whole problem. You might have to throw away something and start over. You might have to put it to rest, go and sleep, get up the next day and continue. That is how it is, right? It is not always easy, it is not always fun. But if you stick to it and you work it how you're supposed to work it, it will be worth it. All right? So we continue. So x squared into 2x cubed is 2x. 2x by x squared is 2x cubed. So we minus in. 2x by minus 2x is minus 4x squared. And 2x by minus 3 is minus 6x. So we minus in now. 2x cubed minus 2x cubed is 0. Boom. Minus 39x squared minus 4x squared is minus 39x squared plus 4x squared. Minus 39 plus 4 will always give you minus 35. Alright? So minus 35x squared. 64x minus minus 6. 64 minus minus 6 is 64 plus 6, which is plus 70x. Alright? And then of course you bring down the 16 from on top there. So we divide in again. X squared into minus 35x squared is minus 35. So you're seeing it looks familiar because we went through this already. The only difference is that we would have tinkered with the last term here to engineer a situation where we actually have a remainder. Minus 35 by x squared is minus 35x squared. Minus 35 by minus 2x is plus 70x. And minus 35 by minus 3 is plus 105. So your remainder now is 16 minus 105, which is guess how much? Minus 89. That is your remainder. Okay? So just as we did in the previous occasion, we're going to write out the completed version. So we could now say that x to the power of 4 minus 42x squared plus 64x plus 16 divided by, what are we dividing by? Right. X squared minus 2x minus 3 is equal to x squared plus 2x minus 35. Remainder minus 89, or we could write it out as x squared plus 2x minus 35 minus 89 all over x squared minus 2x minus 3. Alright? And that is what will happen when you divide one polynomial by another polynomial and you get a remainder. Alright? So that is what it is. That's what it is. So at this point, of course, after you work the requisite exercises that would accompany this video and the video preceding, at that point now, you will be prepared, you'll be ready to step into the remainder and the factor theorem, which is, I wouldn't say it's a shortcut method. What I will do, I will go through the derivation. I will go through the process of deriving the remainder theorem and the factor theorem. All right, and once we derive it, we will be able to express it, and more importantly, we will be able to use it. Good? The remainder and the factor theorem is one of those topics in AdMaths where people start to get a little queasy. So the long division, generally speaking, people will be able to do that, although sometimes you find people getting problems with it when you have the negative sign. Sometimes people will get problems when you have a situation like this, where one of the terms are missing from the original polynomial. But remainder and factor theorem is where most teachers start to teach the CSEC ADMAT syllabus. All right? Now you notice I would have gone through a whole lot of work before I get into the remainder and factor theorem. The reason for that is because you need to have the foundations clean. You need to have the foundations clear. If you don't understand this whole thing about long division, if you don't understand what a polynomial is, if you don't understand the relationship between different kinds of polynomials, then if you skip all that and you start remainder and factor theorem, you'll basically be just going through the motion without really understanding what you're doing. And a big part of how I do what I do with respect to teaching mathematics and ADMATs is about, as much as possible, having the student understand what they're doing. So sometimes I might take a little longer than a lot of other teachers to get to a particular point. But rest assured that once we get to that point, you have it down solid, you have it down cork, you have it down pack. If I could use some colloquial Trini language. All right? So that is it for now. The next step leading out to this is the remainder and factor theorem. The thing starting to get nice. Stay on board. Bring other people inside. Let me go down the road. All right? Boom.